I am 4 minutes late. Jeez. Okay. Switch account. Hello. I think. Gotta find my live dashboard, and I think I am online. Looks like I am online. My audio looks okay. Welcome to Tech Tuesday, and you'll notice I lost the green screen because actually I've got to change my title here. Hold on. Lower third scrolling subject. So this is Tech Talk Power Systems Engineering Library. All right. I was just listening to the 70E meeting, so I was I got carried away in the last dialogue. They're talking about possibly going to Saturday. And I know that scares a little bit of a few people. But welcome to Tech Tuesday, and I'm Thomas Dimitrovich. And today's discussion, I've had some questions from some engineers who are relatively new to the business, new to the industry, and they were asking about what, fundamentals. What are the things that what are the references that that I would recommend, and things like that. So I thought it would be a good idea to get rid of the green screen and talk a little bit about what I've found useful over my career as a power systems engineer. And maybe that is of interest to you. So that is the focus for today. And hopefully you had a chance to join in on our discussion at 12 o'clock Eastern today, because we talked about the plan review with two very good electrical inspectors. And I thought it was a great discussion today. Okay, so let's talk about, and I was just, I was in the process of putting some time current characteristics. So I was doing three things. I was getting ready for this live event. I was monitoring 70E. Actually, four things. I'm working on a PowerPoint presentation that I have to do next week. And I was developing some time current curves for a good friend of mine who asked me for some input. And my problem is I have squirrel syndrome. I don't know if you've ever heard of squirrel syndrome. But that's when you go squirrel and you just get sidetracked. And that's what happened to me. So great to see you, Ryan and Haragovind. Hopefully I got that right. Okay, so today's discussion, Power Systems Library. And here's what I would start out with. From a very basic fundamental, I would say you need a good calculus book. This is the calculus book that I used when I was in college. And it's Howard Anton, and this is a second edition. So I am, I would say I'm probably showing my age, but you need a good calc book. Because calculus is going to help you with derivatives. If you get into derivatives, it's going to give you some of those fundamental equations that, hey, Felix, technical social distancing network, active and proud. So Felix, you probably, and Tamaki, last year, if you remember when I started, I moved from over there and I moved to here, and I didn't have a green screen at the time. So, and you might find my bookcase familiar. So we're going over fundamental books, and I think a good calc book, and personally, I don't have druthers on whether or not you used this one or some other. I just think it's really important that you have a good calc book. So this is I would say would be a fundamental. Now, from a mathematics perspective, the next, and I found this one I don't know how to say it, but it's Kreisig, Advanced Engineering Mathematics. I like this book so much. I actually bought two of them. So I have two copies of the exact same book. One has a dust cover, and one does not. It was published by Wiley, and this one I bought this online. It came from the Office of Naval Research, so it's probably a collectible. I'll show you. If you look, most of the books that whenever I'm using books like this, you'll notice I will tab these things. I don't know if you could see them, but I tab my books. So my tabs are, I'll just give you an example, Laplace transforms. So the Laplace transformation is one area. Vector analysis, and I would say vector analysis, if you think about power systems engineering and what we do, we deal with vectors, whether it's a two-dimensional or a three-dimensional vector. The power triangle is a good example. IV cosine theta. P is equal to IV cosine theta. You're describing a vector P because you're describing, maybe Z at an angle of something, right? So we work in vectors, and this book helps us understand complex numbers, complex analytical functions, how you add and subtract complex numbers. And what I mean by complex numbers, remember, if I'm dealing with the power triangle, I have my real and reactive and my hypotenuse. And if I want to add triangles together or divide triangles, if I have a vector, like say it's VA, which is p squared plus vars squared, real squared plus reactive squared, the square root of that gives me my VA, my hypotenuse. If I want to add those, say I had Z at an angle of 30 plus or divide that impedance by Z at an angle of 25. How do you divide vectors? And power systems engineering is full of that. There's a chapter in here on complex numbers, triangle, inequality, triangle, multiplying, dividing, adding triangles. So I was looking for a good book to be able to come up with all of the analytics, and this was a really good book for me. Now, granted, I used it once, and I think I even took this on my I took this with me to my professional engineering exam. But in here, like just to give you an example, in chapter .4, they talk about complex numbers, and they explain what complex numbers are, what the A vector is, the multiplier, and they help us understand how to multiply complex numbers, which would be Z's. So if you have two impedances, which have a real and reactive component, how do I multiply two impedances that have a real and reactive component? How do I divide two impedances? And why would I need to do that is if I'm drawing a circuit and I have a complex, I have two impedances which have a real and reactive components in parallel or in series. I need to know how to add those. In my class last week, I explored with my class last week was at National Training Institute, NTI, up in Michigan. And it was a good class because we had a smaller group. And what I did was I just asked them, how do you deal with the real and reactive? And what those guys and gals do a lot of is adding and subtracting. They really don't get into multiplying and dividing. And when you would need to do that is if you're dealing with complex circuits where you are trying to create your Thevenin equivalent, and you are reducing your circuit down to a single resistance and reactance. So you'll need to take conductors that are in parallel, and you have to multiply the top, right? So if we want to take two conductors and come up with an equivalent impedance, what do? And they're in parallel. I multiply the two impedance values divided by the sum of the impedance values. And if my impedance values are a complex number, meaning a real and reactive component, then I need to multiply two numbers together. And I need to do that using complex variables. And this is my reference. And I did a class on a power systems. We calculated fault currents and we used the per unit method where I was using real and reactive, and we had to do the math. And this was my reference. It's a thick book. There's probably I haven't used all of this. My primary go-to in this reference is around complex variables. So, so mathematically, this, hey, Venetius, good to see you, brother. Mathematically, these are my three books. I'd say any calc book that you used when you were in school, and it should have, I'll just give you an example. It should have derivatives in there. It should have derivatives in there, and I'm just looking for some of the So I've got my differential equations. It should have trigonometry, inverse functions, hyperbolic functions. These are your cosine, cosh, tan, tangent, tang, TANH, COSH. All your hyperbolic functions, that is a very important aspect of your power systems library that you'll need to include. And what else? You know, your cosine, your inverse cosine, your logarithm, your log functions, your exponential factors. So good reference for you. This is second edition, Howard Anton. And this Advanced Engineering Mathematics is Erwin Kreisig, K-R-E-Y-S-Z-I-G. So two important references for you. All right, so that's like the fundamentals. Now, the other one I have, which, you know, and I can tell how much I've used these, and I know what this book is. This is Methods in Numerical Analysis, Nielsen. I have not used this one as much. I think I probably bought this and dropped that out and grabbed this one. It had everything I need. But numerical analysis is an important part if you get into equation development. Think about the arc flash equations that we use for incident energy, IEEE 1584. The development of that equation, arguably, this book here, Methods in Numerical Analysis, this book, this was the one I used in college. And when I graduated, Elementary Numerical Analysis, Atkinson, out from Wiley Publishers. So I used, and look, you might not be able to see it. Let's try MobiCam. Look at the text. Look at all the writing I've written inside this book. So I'm an individual that I treat my books are tools. So I write in them, I highlight in them, and when I was when I wrote a program that did basically a coordination study and generated curves. And what I would do is my program, you would select overcurrent devices, 2 of them in series. I would extrapolate and generate the curves based on equations that I used to do either a fuse curve or a circuit breaker curve. And I did this in college, my senior year. And what it would do is you plugged in a fault current value and it would do the math and tell me if the clearing times minimum and maximum clearing times of all the overcurrent protected devices upstream, and it would give me my result. But all of the equations for developing the very long equations that deal and addresses error, right? Because you're fitting an equation to match data points on a curve. And if you think about incident energy and arcing currents, that's basically what Dr. Lee is doing. He is running a test, establishing a current value, putting it on a X and Y axis, and then drawing a line, and then using numerical analysis, which has, and that's why they have this picture right here of it's basically creating an equation that draws a line based upon an X and a Y axis. And if you wanted to go three-dimensional, you can do that too. But I think for a majority of what we do is probably, your X and Y axis is all we need. So I would highly suggest that you're going to want a decent book in numerical analysis if you get into any level of curve fitting, creating equations and that match a curve. If you're not going to get into that, obviously you don't need the numerical analysis. But in my career, I used these when I wrote programs. I wrote software applications that would draw the TCC curve, basically, and then do some comparisons. I also used the numerical analysis whenever I was doing any type of curve fitting. So I did some plots and drew some basic lines in my software applications. So, and some of those were used in the nuclear world for calculations on single phase systems and safety related circuits. So two very good references for you. Now, another one, basic circuits. So circuits. So the basic fundamentals, you've got to have a good math foundation. You should have your numerical analysis if you need that type of depth. Basic circuits. So I have my book from college, Basic Electrical Circuit Analysis. And this is David Johnson, John Hilburn, and Johnny Johnson. How'd you like to have that name? Hey, I'm Johnny R. Johnson, coming live to you from TSDN. So basic circuits. Now, this was a good book. And what is this good for? This book helped me understand voltage division, Kirchhoff's laws, current division, all of my nodal analysis. I'm just looking at my tabs here. Watt meters, three-phase versus single-phase calculations. So a basic circuits book is, I think, one of the fundamentals. Now, somebody gave me this, Benny Taylor. Man, that goes back. Crystal River Unit 3 down in Florida. Benny Taylor, great guy, absolutely great guy. He and I did a lot of work together in that plant, and he gave me this book because I was always reading. I was always doing something from an engineering perspective and mathematics. So he gave me this book. This is Circuits, Devices, and Systems by Ralph J. Smith. And great reference, Circuits, Devices, and Systems. This is a third edition. It's pretty worn, but I didn't put the wear and tear on it. Benny did. Benny was a sharp individual as well. And he's still out there somewhere. I haven't talked to him in a long time. And Benny, if you're out there, shoot me a note. Love to chat with you. So there was similar principles that you'll find in here. This one, and I have, these are my tabs. Look at this. I got green tabs across the top, and I got yellow tabs down the side. The green tabs, forced response, signal waveforms, natural response, forced response, short circuit, AC circuits, network analysis, diodes, magnetic fields, transformers, DC machines, and AC machines. And then along the side, I've got V&I division. I've got sinusoidal, what is that? Sinusoidal waveforms, resonance, transformer, and transistors, transistor circuits. And then I have transformer efficiency. And what's this tab here? Open circuit and short circuit tests. Those are what we do on transformers. So this book, and the reason I got this one, and I would say if I had to pick, I'd pick this one. If you can get it. Circuits, Devices, and Systems, Ralph J. Smith. Yeah, Tamaki, this book was much more comprehensive than this one. And I liked it. I mean, there were things that I needed, like efficiencies on transformers. This had, and it seemed more practical. And I'll give you an example. For power applications, important external characteristics are voltage ratio, output power, efficiency, and voltage variation with load. And it may be obtained from manufacturer specifications, from experimental measurements, or from calculations based upon circuit model. And in here, they talk about the nameplate ratings, what's on the nameplate, what it means, how to calculate efficiency based upon what you get off the nameplate, and when you need to go back to more information. And the other cool thing is they have the questions in here, the problems, and they have exercises, and they have problems, and I believe. And this is the other thing I hated was some of these, they have answers to selected exercises. So they do have some answer keys in the back of this book, which was very attractive. Because when you're self-studying, it's great to do problems, which is another topic. And I've got some other books up here I will bring on the table because doing problems is where it's at. I don't care if you're studying in school, if you're studying power systems engineering in school, or if you're just trying to learn more. The repetitive nature of doing studies is absolutely very important. Very important. All right, so I'm just looking to make sure I don't have any questions over here. Okay, so I highly recommend this one, Circuits, Devices, and Systems. And really, honestly, if you are in engineering and you did have a good circuits class, that is a great reference for you. Hey, Robert from Omaha, we're talking library, buddy. The green screen is down. All right, another one. This is more electronics. Electronics 1.7. I don't know if you guys know about this one or have seen it. I've got some. What is this? All right. Okay. All right. Look at this. This is my bookmark for this book. For motion discomfort and baby diaper disposal, please place in waste receptacle after use. Not for toilet disposal. Do not place in seat back pocket after use. You gotta see this. This. I didn't even know this was in here. Look at this. For motion discomfort and baby diaper disposal, please place in waste receptacle after use. Not for toilet disposal. Do not place in seat back pocket after use. Could you imagine using this and putting it back in the seat back pocket? I don't know why the heck I have these in this book, but that is the bookmark that I have. So I've only got 2 tabs. Let's see what I tabbed on this book. I can't believe that. That is funny. Amplifier circuits. Oh my God. Okay, I remember now why I got this book. So I remember now. So amplifier circuits and then audio amplifier circuits. All right. So the reason I've had this book, I can't remember when I got it. I got it a long time ago, but and I'm still going to do it. I'm going to build my own guitar amp. So I was coming up with my design for my amplifier, and that is why I tabbed those books. but I don't use this book as heavily. So, but it is out there. It is on my shelf. So that is a reference for you. All right. So those are my circuit books. So we went over calculus, we went over numerical analysis, and we went over circuits. The next big one, what's the next big topic in power distribution systems? Motors. I'm going to give you my references. All right. Okay. This guy right here, Electric Machinery, Fitzgerald and Kingsley. Okay, Fitzgerald and Kingsley. Hold on. MobiCam. So this is my reference that I used in college, Fitzgerald and Kingsley, and I can tell you that I mean there's a lot of writing I have in this book, and this book helps us understand motors, how they're made, the math behind the iron and the windings. There's a lot of heavy, deep theory in here, but it does help us understand the circuit for that system. We're washing it out. It does help us understand the circuit diagrams for these these different diagrams, almost like you would have like for transformers and things like that. So this is such a good book that I bought the latest version. Well, it was the latest version, the 5th edition. I don't know what edition they're up to now, but Fitzgerald and Kingsley. And look at all the tabs I got on the top. I'll just go through the tabs I have on the top and on the side. Magnetic circuits, transformers, energy conversion, rotating machines, synchronous machines, synchronous steady state, and then synchronous machines transient, polyphase induction motors. I mean, that chapter should be a lot thicker. And I mean, that is like the core of power systems. Industrial motor controls, variable reluctance, DC machines, single phase induction motors, 3-phase circuits. And then on the side here, I've got transformer efficiencies, poles. So this talks about how many poles and the math that you need to do to come up with some important parameters. I've got adjustable speed drives. I've got no load tests and motor starting and phase sequence. So let's see, Ryan, I have a bookcase full of the most boring to the layman books. Yeah, every NEC since late 90s. Useful now. They certainly collect a lot of dust. Yeah. Well, so and then I bought this Steve Chapman, Electric Machinery Fundamentals, and I tell you what, I took this on a lot of planes when I was studying for my PE. This is very similar to this book. Now, the other thing I do have is for this book here, I've got the solutions manual. So this is, and I love the solution manual because it's all, whoever did it hand wrote everything. So all of the problems in the back of each chapter, I've got the solutions for. So I can go through and do the equations or look at the problems at the end of every chapter and actually check my answers to make sure I got them right. That was critical for me in studying for my professional engineering license. So motors are a very important aspect. So these are some of my references. These are my, I would say, engineering references. Here's another one. This is the Electric Handbook of Electric Motors by Richard Engelman and William Middendorf, I presume. This book is, I'm not sure what this is, 1995. And there's like 47 authors on this inside. So here's some of the chapters: types of motors and their characteristics, motor selection, induction motor analysis, synchronous motor analysis, direct current motor analysis, testing for performance, motor control, motor insulation. And if I'm not mistaken, I'm just looking at some of the names. What's funny is that if you look at some of the names in these books, you'll recognize some of the authors. Like motor protection, there's Vincent Saporita. So Vince Saporita, if you know Vince Saporita from the Busman Group, he helped write one of the chapters in here. So good reference, motors. I'm just looking to see what other good books I have on motors. Here's another good book, Transformers. This book is on transformers, and it's called Transformers. McGraw-Hill for the Transformers for the Electric Power Industry. Richard L. Bean, Nicholas Chacon, Harold R. Moore. So there's the names: Richard Bean, I don't know what the heck, Harold Moore, Edward Wentz, Wentz, McGraw-Hill Company. I like this book personally. I enjoy. This is interesting. It's Westinghouse McGraw-Hill Engineering Books for Industry. So, So this was I'll give you some of my tabs on this one. I've got magnetic circuits, inrush current, maintenance, load and no load tests, tap changing, efficiencies, watt meter. Now, if you think about it, we had some similar chapters in the other books, and but every time I pick up a different book, everybody has a different perspective on it, and sometimes it's sometimes one person's way of explaining something is better than another person's way of explaining it. So that's why I have such a good I have a good library in that regard. So I was a CS turned EE. I was an RS-45 guru, still am. Amen. From writing drivers to the electrics. Fortunately, so much of that still exists. Yeah, I feel old, but feel useful. The underlying never changes. Yeah, that's the thing. When I look at these books, like Fitzgerald and Kingsley, this book here, most of my books are older, and the physics doesn't change. So, and it's our industry doesn't change in general very fast. So, you can't go wrong. Can't go wrong with having a good library. A few other good books. Okay. Okay. This is a special book. This here is a very special book. I don't know what I'd do without this book. It is highly tabbed, as you can see. I even wrote my name on the front because I do not want to lose this book ever. It's look, even on the inside, I got property of Thomas A. Dimitrovich. I put a nice binding on it. This is the Industrial Power Systems Handbook. Donald Beeman was the editor. This is a first edition, 1955. And if you look pretty much every chapter, I mean, the big names are in here. You've got all the big names. Cook, so Shelby Cook. So this is Cook and Carr, Elements of Electrical Engineering. Cook and Carr. Cook is in here. I don't know if Carr is in here, but this Industrial Power Systems Handbook is a great reference. the first chapter in here in short circuit calculations, I think, yeah, short circuit calculating procedures helped me understand the asymmetrical waveform and symmetrical waveform. I think this was a chapter I could read over and over and over. I'll give you the chapters here. I'll just give you my titles. I have short circuit calculation per unit, combining impedances, equivalent circuit. This is the only book. This is the only book that I have ever found that helps you convert the utility short circuit current into a per unit impedance that you can use in your power systems study. In fact, in my one video where we did a detailed analysis, a hand calculation, I used the equations from this chapter. I also, in my video on infinite bus, used these equations to calculate and convert the utility available fault current into a per unit impedance. So, and what I like about this, so to give you an example, it says converting utility system reactance to per unit ohms, if given in percent ohms reactance on a kVA base, different than that used in the study, they give you the equation. If given in short circuit kVA, convert to per unit ohms, and they give you the equation. If given in short circuit amperes, convert to per unit ohms, and they give you the equation. So what's really awesome is it's practical, it's real, and it's very helpful. There's the per unit. I got combining impedances, equivalent circuits, symmetrical components, voltage drop, calculations. I mean, voltage drop isn't going to change. Motor starting, series capacitors. Now, motor starting, obviously, that's changed considerably. I've got power factor simplified, capacitor circuits, series capacitance, device numbers. Now, these device numbers, these are all of your relay device numbers and functions for, let's say, switch gears. Like a 50-51. 50 is overcurrent. I'm sorry, instantaneous overcurrent relay. 51 is your time delay overcurrent. So a 50-51 relay gives you overcurrent and instantaneous. All of those functions and numbers are in here as well. So great reference. I would never have a library. Look at this. I even put my name on the bottom. I put my name on the top. I wrote my name on the back. So this is a must-have for a power systems engineer's library. Another important book, Blackburn. The Blackburn book on protective relaying, principles and applications, J. Lewis Blackburn. The book I have is I'm not sure what edition it is. Look, I care about a book when I got my name all over it and it's tabbed. I mean, this book here, I mean, I've read this book numerous times inside and out. Symmetrical components, shifting, sequence, so phase. If you need to understand how when you put CTs in delta or Y, the phase shift on the secondary of those CTs, how they add up in the delta, how they add up in the Y, how they do the conversion. It's all in here because you need to know that in protective relaying, especially in your medium voltage. Device numbers, per unit, symmetrical components, instrument transformers, all about instrument transformers, all your inputs, your voltage, your ratings, the sizing of those, how to do a CT burden calculation is right here. If you've never done a CT burden calculation and you deal with CTs and you're designing relaying, you need to do CT burden calculations. This is a great reference to help you understand burden calculations. And if you don't know what burden is, you need this book even more. Let's take a look. Hold on. Distance. Oh, yeah, your distance relays. So if you're in the medium voltage and you're dealing distance relays, the settings, all the settings is here. Transformer inrush, transformer differential protection, motor differential protection, under reach. Oh man, under reach, and yeah, there's just if you're into protective relaying, very important book. What was the first book? Industrial Power Systems Studies, Industrial Power Systems Handbook, Donald Beeman. Here, I'll do a MobiCam, Obi-Wan Kenobi. This is the book. Industrial Power Systems Handbook, Donald Beeman. This is a first edition, 1955, but important reference in my opinion. So you'll see all of my tabs and all of my tabs on the top. I mean, this is you just can't go. In my opinion, you can't go wrong with this book. All right. If you are into stability, power system stability studies, I learned out of these, and the books that I learned out of I'm a Jerry's kid, Jerry Salvaggi. He taught us power engineering in school, and he did our system stability classes. Kimbark, Kimbark, is the name of this guy. And IEEE came out with, so power system stability, there's a 3-volume set, Edward Wilson Kimbark, elements of, and this is, the first one is elements of stability calculations. So volume 1 is elements of stability calculations. Volume 2 is power circuit breakers and protective relays. And volume 3 is synchronous machines. And so power system stability, you'll notice I don't have much bookmarked in here, but if you're taking power systems engineering classes, then this will be a great reference for you. And again, it deals with the interaction between motors and generators and making sure everything is in step with each other and whatnot. And what was nice was IEEE Press, Power Systems Engineering, came out with a power system stability volumes 1, 2, and 3, and they put them in a nice packaging here. And MobiCam, there's the ISBN number, 076031135-3. I think it's 76. No, it's 78. 078031135-3. That's the ISBN number. And again, it's Power System Stability, volumes 1 and 3, 1 through 3. And this was IEEE Press, Power Systems Engineering System, Paul Anderson series editor. And it was a classic reissue. And when you have something that's a classic reissue, you can't go wrong. So Power System Stability, Kimbark. I'll give you a few more examples. I should have put this in there too. Symmetrical components, Wagner and Evans. So Wagner and Evans did the symmetrical components. And if you CF Wagner and RD Evans, MobiCam, this is a reference for symmetrical components that when you're doing power systems analysis, short circuit studies and things like that. That's an important reference to help you understand how to how to break the system down into positive, negative, and zero sequence currents. Really important reference, in my opinion. I bought this book. I had my book taken from me, and then I bought another book. So actually, I had the original book I had was an old first edition, and I found this company, and I think they were out of Canada, and this was a very long time ago. And again, I put my name in this one too. So that's a great reference. Another one. Another important series of books. I'm looking for them. Here they are, right here. All right. And you can always tell when I really find something useful, I will buy multiple editions of the same book, because as revisions come out, they change. And all four of these books, and I'll tell you which one I started with. This was the first one. I can't tell you where I got this. I really can't. This has just been in our family for a long time. Alternating Currents, Kirchner and Corcoran. So there's the title, Alternating Currents, Kirchner and Corcoran, Corcoran, Wiley and Sons. This is a third edition book. And this is a third edition book. And I'll tell you what I love about this one. It's a good overall. They have general concepts of AC circuits. There is vector algebra, single-phase circuits, three-phase circuits, transformers, symmetrical components, transmission line theory, and transmission line theory, Woodruff. Where's my Woodruff book? Woodruff. Here we go. Transmission line theory, Woodruff. Electric power transmission from Woodruff. I got 2-second editions. I'll put those on the side because we're going to talk about that. But this book here is a great general overall. And I'll tell you what, between all four of these, so I've got two copies of the first edition. I've got a third edition, and I've got a fourth edition. Alternating Current. They are pretty much all the same. Not too much difference between the first and the fourth. Maybe some additional stuff, but great book. I mean, the fact that I have 4 copies of the daggone book tells you I really love that book, and a lot of great information in there. I'll put that over there. Now, transmission. So in college, I did transmission line theory. And this is talking about transposing. You know, when you see a transmission line, how you got A, B, and C, and then every so often they switch and rotate and whatnot. We learned out of Woodruff's book on transmission lines. It's electric power transmission, Woodruff. MobiCam. So, principles of electric power transmission. And I'm going to see if there's, here we go. Principles of Electric Power Transmission by L.F. Woodruff. This is a second edition, New York, John Wiley and Sons. I don't have ISBN numbers or anything like that. This is probably before ISBN was even created. They talk about skin effect. They talk about your inductances and reactances. And what's interesting, this is the resource that if you want to understand the inductance and reactance of a conductor in relationship, because the spacing, say, of conductors within each other, how far apart they are, whether they were round circles and whatnot, or if there's 3 of them, 6 of them, you will know how to calculate the impedance of a conductor based upon the relationship of the strands. And that's what this goes to. It talks about skin effects, talks about capacitance, short circuit currents and voltages, circle diagrams, calculating fault currents, and then there is power system stability. So it dabbles in power system stability a little bit. But this is transmission line theory at its best. I bought this one. It said a second edition, but it was a different color book. So this one was red. I didn't get it, didn't understand why. These things were written in 1938. And if I just look at, they both say John Wiley and Sons. This one has 1930. Oh no, they're both second editions. I'm not sure. The print is different in these books. So Massachusetts Institute of Technology. Woodruff was the associate professor of electrical engineering back in 1930s. So this is a great reference if you're into transmission line theory and you need transmission lines. This is a good read, must have on your library. If we're talking transmission line theory, we would be amiss if we didn't mention another Bible, the Westinghouse Electrical Transmission and Distribution Reference Book. This is a Circle Bar W reference book. It is, when I bought it, ABB, Asia Brown Boveri, bought the rights to this book. This is a really good reference, talking about symmetrical components, aerial lines, cables, transformers and reactances, machines. I mean, we're talking large, and look at this. This chapter on machines was edited by or revised by C.F. Wagner. Where do we know Wagner from? Wagner and Evans. There it is. C.F. Wagner, symmetrical components. Wagner and Evans. That's where we know Wagner from. And Wagner was a contributing person to machine characteristics. So great reference. I used this heavily back in the day. It is dated, but again, hey, Ireland, there you go. This is for you, buddy. I mean, you brought this up. You brought up the whole aspect of power systems and getting into the business and all that good stuff. So I'm just going through a bunch of references. So thank you very much for the feedback. And William Snyder too. Pure tech, not a bit of fiction in the collection. Definitely a Tech Geeks library. Fiction makes you sleepy. Here's another. This is another oldie but a goodie. Silent Sentinels. Silent Sentinels was a Westinghouse protective relaying book. This goes back, look at this, priced $1. So Silent Sentinels is a reference book that was put out by Westinghouse, priced $1. Westinghouse Electric and Manufacturing Company, and it has a TD number associated with it, and that's not TD as in Thomas Dimitrovich. So what this talks about is the application of protective relays, distance relays, phase negative sequence relays. It talks about calculating short circuit currents and voltages, vectors for relay systems. So a great reference, direct current system protection, and it goes through a lot of older reference materials. I think I have this primarily for, I love antiques, and I love old history. So that's another good book for you. Westinghouse and Vikings, LOL, I'd certainly read it. Amen. And a couple other books. Applied Protective Relays, Relaying. This is, again, a Westinghouse reference. I've got 2 copies of this. Bob Elms gave me his copy. But look at this. Look who wrote in this one. So, Introduction to General Philosophies by Blackburn. Where do we know Blackburn? Where do we know Blackburn from? Where's my Blackburn book? Where's Blackburn? There he is. There's Blackburn. So, Blackburn is an author he's all over this. So you got Blackburn in here, you've got Elmore, you got Kresser, you've got also a gentleman I worked with wrote a chapter in here. Where is his name? Kresser, Wilson, Ray, Kresser, Ray, Heinemann, Elmore. I can't find his, Eric Udrin. There you are. Load shedding and frequency relaying. I'll give you some of the titles of this book. Pilot wire protection, transmission line relaying, system grounding protective relaying, line and circuit protection, station bus protection, backup protection, testing and maintenance protective relays, reclosing and synchronizing. So applied protective relaying, if you are a relaying engineer, ooh, hurt my hand. Protective relaying is a very important book for you. And I would marry that with the Blackburn book, Silent Sentinels. And also, and I don't know if you're going to find this, but this is a GE reference called Relaying the News by General Electric. And this is a binder. I don't know if you'll find these at all, but these are all notes that came out on all of their protective relays. And you know what? You probably wouldn't need this anyway. This is more historical for older relays. So a lot of the relays that are in this reference no longer are sold. So, okay, so we hit relays. We hit all of our math. What else? This is a relatively good book. Distribution Systems, Engineering Reference Book, Electric Utility Engineering Reference Book from Westinghouse. This is volume 3. I wish I knew where volumes 1 and 2 were. I've never seen volume 1 and 2. They talk about load characteristics, sub-transmission and distribution stations, primary and secondary distribution, secondary network systems, distribution transformers, voltage regulation, application of capacitance. So again, there's a lot of good information in here, but I think you would need to be directly in the utility industry to get some value out of this one. The color books. I'll just grab a few of them. This is the IEEE Brown Book, Power Systems Analysis, IEEE Standard 399, and you'll look, the date is 1990. I bought this set back in 1990, and I'm telling you, I love this. I love this book, these books. This is the Red Book, IEEE Standard 141, 1986, okay? And this is the Buff Book. IEEE Standard 242, 1986. This is Protection and Coordination of Industrial and Commercial Power Systems. These books, especially these two, if there was any of the two color books, I would highly recommend the Red Book and the Buff Book, because those books will help you understand calculating fault currents and doing coordination studies. Two very important books, more so than I think the Brown Book. The other, there's an Emerald Book, which is the Emerald Book is on powering and grounding sensitive electronic equipment, IEEE Standard 1100. Again, this is an old book. You could probably still find it on eBay. But that helped me when I was designing I was designing a security system for Crystal River Unit 3, and I was trying to learn how to ground the shields on data signaling lines. You ground on one side, but you don't ground the other, and all those principles about harmonics and proper grounding of those sensitive electronic equipment. The Emerald book, hands down, my key reference. And then I've got the gray book, which is IEEE standard 24119. This is 83. This is the, my cover is ripped, electric power systems in commercial buildings. Another good reference for you. I do have the rest of that cover in here. The green book is on grounding, good reference. You'll see them if you just look up the color books. In fact, we've added some more color books. The grounding book is IEEE standard 142, grounding of industrial and control power systems. Great reference. I'm not even going to tell you that one. That's the gold book. I wouldn't worry about it. And then I got 2 copies of the brown book. A brown book was underwhelming for me. Didn't get much out of that. I got more out of the red book and the buff book. So, but I would definitely have these on my in my library. I would not, as a power systems guy, you just can't. You can't not have it. 2 negatives. You got to have it. People wrote these books out of passion only. You know what? You're absolutely right. That's another. So here's another part of the picture of the pie. When I look at these books that were back in the, what years? I mean, think about it. These guys had jobs. You know, like we have jobs. I have a job. And I do a lot of this stuff extracurricular. These guys were either teachers, some of them teachers, and I think that the older books are easier to understand. And I have a theory behind that, but I'm not going to share that. Okay, I said earlier, studying for the PE, some key books that I used. So when I studied for the PE exam, I did questions. Questions after questions after questions. And the principles and practice of the PE, they give you an exam book, exclusive developer of the PE exam, where you just do problems. But then I like to seek other problems. And sometimes I make problems of my own I can't solve. But anyway, handbook of electric power calculations. And it came with a CD, the complete text of the book, over 100 live interactive formulas, completely searchable. I have never used a CD. I never even put it into my computer. I ripped it out of the back of the book, and it is gonzo. But there's basic network analysis. There's instrumentation, DC motors and generators, transformer calculations, 3-phase induction motors, single-phase induction motors, single-phase motors, synchronous machines, overhead transmission lines and cables. So there are a lot of really good problems in here, and they do give you the answers to them as well. So this was a good reference for me. Also, there's another one, Electric Power Systems Engineering Problems and Solutions, McGraw-Hill Book Company. And I had short circuit analysis, symmetrical components, transformers, magnetic circuits, synchronous machines, relaying. So this was a good book. And for, at least for me, I did a few questions out of there. They were helpful. This one has no tabs. I didn't put my name in it at all, and I don't know where I bought this from. I've got a few books from Albert Cellarini out of McKeesport, Pennsylvania. I probably bought this online on eBay or something. This is Problems of Alternating Current Machinery. There's the title. Problems in Alternating Current Machinery by Waldo Lyon. It's a second edition, fourth impression. I don't know if that makes a hill of beans. It's 1914, 1928. I did not use this book as much. I think it was more a, I don't know. I got the answer booklet in there. I think, I don't know. I had it and I don't know. It's on my library. I don't know that it needs to be on yours, in your library. But that is a book that I have, and these are just 4 references that I use to just do calculations and test myself. 2 other good books. I got this one kind of late. This is Turin Gonan. I don't know. Gonan the Barbarian. I don't know. It's Electric Power Distribution System Engineering. And by Turin, Gonen, McGraw-Hill. And it said California State University, Sacramento. So, a lot of good information in here. Fault calculations, transformer paralleling, regular efficiencies, 3-phase transformer connections. I got distribution substations, capacitors, voltage drop, load characteristics. I found it interesting enough that I tabbed this. I can't say I have lived in this book a lot, but a lot of what I see and hear, again, or in a lot of these books that we already talked about, but it's all in one place. So it seemed like a relatively good book. But again, I know somebody who does use this a lot. And based upon their recommendation, I added it to my library, and I did buy it. I did buy this online. So I found it in a used environment. I bought this one, though, new when it came out. Dunky Jacobs Shields with Conrad St. Pierre. Industrial Power Systems Grounding Design Handbook. In this book, Dunky Jacobs talks about the historical references of grounding and bonding, or grounding systems, medium voltage, low voltage, all that good stuff, all the different definitions. What the global grounding system is, neutral instability and ungrounded systems, the problems with ungrounded systems, and if you've watched some of my materials where I talk about the history of ground fault protection of equipment. Remember, GFPE was introduced in the National Electrical Code in 1971. And before that, they dealt a lot with the ungrounded systems. And the reason we had driven the need for a ground fault protection of equipment was because we started to ground systems, which increased the fault currents. We went from a 208 volt system to a 480 volt system. We went from an average of a 600 amp service to 4,000 amp services. And that drove incident energy and explosions at some service entrance equipment. And the only solution in 1971 was ground fault protection of equipment. So this book gives you some of that history, which is really cool, because Dunky Jacobs was all over that. Very good reference on grounding and bonding. It is a relatively newer addition to my book, as opposed to a lot of the other books that I've talked to you about. I have used this book sparingly so far, but I can see this being a go-to reference for me when it gets to industrial power systems grounding. and the design of systems when it comes to grounding. So good reference for you. Outside of the code books, which I go back pretty far in the code book, but the handbooks are good, and the code books, got to have them, good historical value. I think that's, and NFPA 70E and any other NFPA documents. That's sort of my, I would argue that's probably a good overview of some of my references. I mean, I've got other books over there and down here from various classes I've taken, but and you know, all the different code change books that are produced, from IEEE to Mike Holt to NECA, Electrical Training Alliance, IBW. I've got all of those books, and all great references. So that's my library, and I think I've conveyed the books that I think are of most interest, but they're all basically around power systems engineering, and very little on electronics. On the electronics side, you know, I've got my data and communications, my understanding data and communications from fundamentals to networking, Gilbert Held, great reference for that. Oh, and metering, and you know, and power management. I've got a lot of power management books across the board. I wouldn't say there is one power management book that I would say covers everything. I sort of dabble in a lot of different areas, but those are my big references and reference books. And maybe what I'll do is maybe I'll take some of my other references, because I've still got a lot of other really good materials that I use. The available fault current posted would be vital to the next electrician coming in to do remodel. William Snyder, can I explain the reason having the available fault current posted would be vital to the next electrician coming in to do a remodel? So posting the available fault current, why would I want to do that? What do we use available fault current for? Three things. One is for interrupting ratings. We have to look at our equipment, make sure that we evaluate the capabilities of the equipment with the available fault current, to make sure that we do not exceed the ratings of the equipment. Very similar to we post voltage. Why do we post voltage? Because we want to make sure that people understand what voltage of equipment you need to buy, whether breakers and fuses and relays, everything associated with that. Short circuit current ratings. I need to know the available fault current and make sure that I don't exceed the short circuit current rating of equipment. I might even be able to use that information for the table method of 70E. If I'm not living in a labeled environment from incident energy, 70E will let me look at the available fault current and do a calculation and estimate the fault current and determine my level of personal protective equipment. So there are a lot of reasons that available fault current is important. Also, from an interrupting rating perspective, let's say that you are going into a panel board and you're going to add a breaker, add a circuit, and you're going to go to the supply house and you're going to buy an overcurrent device. You need to know what is the interrupting rating that you need on that device, and if it's not the right size, you may spend some money and have to go back again and buy a higher interrupting rating device. Remember, the overcurrent devices have to be able to interrupt the available fault current at the equipment. Just buying a 10K breaker doesn't do it. You can buy 10K, 22K, 42K, 65K, 100K, 200K. You can get breakers in all categories. Their interrupting rating will vary by the voltage at which they're applied. So if I have a 600 rated voltage breaker, I can apply it on a 240 volt system if I wanted to. my interrupting is going to be different. So, James Smith, you're going to buy my entire library for $5 million. Hey, sold. Where do I ship them? Send me the money first, James. Give me my $5 million, and you got every book back here. I'll even throw in some of the magazines I've got. Jeez. But here's my guidance is some of these I acquired going to yard sales, going to half price bookstores. I surf the eBays and I surf the Craigslist and all those. Read the disclaimer. This is not binding contract just for the. Oh, well, James, I can dream. All right. I can dream. So I would say, that's why we would mark that available fault current. Everybody has to know the environment that they're going to be placing devices. So hopefully my little library discussion helped you out a little bit. And if there's anything in specific that you're interested in, if there's a book that or a recommendation on a specific topic, I can look at my library. I can tell you what I use. I know I've given some of my books away. I had 3 copies of all the color books. I gave all of my duplicate books away already to other engineers younger engineers who I thought can use them. So if I had duplicates of things, which you did see a few, those are different editions of the same book. I don't consider that duplicates. Just saying. When you have first, second, third, and fourth edition of one textbook, that doesn't mean you have 4 copies of the same book. But if I did have multiple copies, believe me, I do share them, as I would hope you would too. So thank you. I think I'm going to stop now. I'm really not sure what time it is. I went 1 hour and 20 minutes. Hopefully you got something out of some of my reference books. And you got a little visual behind the green screen, and a little view into my technical library. That's all I have to say about that. Hopefully it helped. Thanks, Felix, for joining in. And you know what? If you have, I always say, if you can share and provide reference materials to inspire others, I think that's a good thing. I think that's why libraries are there. They inspire us. Surf the web. Take a look on eBay. You never know when you're going to find a really good book at a really good deal. Some of these books, like the my Kirchner and Cochran collection, I bought those. I mean, they were like $10 a piece, $15 a piece. You can get them relatively inexpensively. You just gotta look. All right. Thank you, William. Thank you, Tamaki. I appreciate it. And everybody out there in Tube land and LinkedIn land and Facebook land. I'm looking at my LinkedIn site. It's hard to find any of the comments or questions coming in. So, Kevin Porter, thank you for joining in on LinkedIn, and Mathur Abbasi, thanks for joining in. So, and I didn't check my Facebook page. I'll just double check that one, see if there's any questions out there. And I forgot to do Instagram again. I did Facebook though, but I forgot to do Instagram. We got one comment. Please take a look at the email I sent regarding the new method for short circuit calculations. Isaac, I will do that. In fact, I saw your note. I've been really swamped. So I will definitely do that, Isaac. Thanks for the note. All right. I think that's all I have to say about that. And Eli Kasanovich, thanks for joining in. Dominic and Sanjeed and anybody else who is out there in Facebook land and LinkedIn land and Twitter land. So if you haven't connected with me on Twitter and Facebook and LinkedIn, let's get together socially. Get out there to Twitter, and I'm there as well. So please, the more we can communicate, the better off we are. So thank you. And I'm going to close up shop. I'm going upstairs after I finish the time current characteristic curve for my Colt. So take care, stay safe, and God bless. And please remember to stay healthy. It's an important part of the puzzle. Thank you for hanging in there with me, guys and gals. Stay out of trouble. Signing off right now.